All right, so in this class, we are going to learn about the normal curve. The normal curve is a little bit different than the probabilities that we've done before because the normal curve is a continuous distribution instead of a discrete one. So we're going to have to use these things called probability density curves, okay? Now, I don't know if I've mentioned this before, but probability density curves are basically like approximated histograms where if you imagined any histogram on a graph, it would be like connecting the tops of the bars to come up with like a smooth curve. So this guy here isn't like a histogram, but you can imagine it's kind of like the overall shape of one. It's basically like a generalization of a regular graph that you would see, okay? Now, probability density curves are very, very important because you can kind of use them to kind of sketch areas that you're interested in. And let's just see some properties here, okay? The area under the entire curve is going to be equal to 1. Remember when we did the 68, 95, 99.7 rule and we shaded in areas underneath the normal curve? Well, if I shaded in everything, right, that would be 100% of the data, which is in decimal form 1, right? So everything shaded together is everything. So that probability has to be 100% or 1, okay? The area under the curve between two values, so let's say I have a value A and a value B, and I shade in the area between those two values. There's actually 2 ways we can think of it, okay? Well, actually 3 ways. First of all, it's the area, right? The second of all, it's the proportion between those two values. So we kind of just call it like the proportion or the percent of the data values that fit between those two values, okay? The last thing it's actually the probability, okay? So the probability is the area between those two values as well, okay? So in this class, we're gonna be given a lot of questions that either ask you for the area, the proportion, or the probability. They all mean the same thing. So don't get confused when you see like probability, proportion, area. They just all mean the same thing, okay? All right. Some other properties of a probability density curve, okay? Let's say I wanted to find the probability of just one value. So like the probability that X was 2, or the probability that we had 4 penguins or something like that, okay? Well, if I thought about that in the context of area, right? Let's say this was like 3 or something. The area under 1 point doesn't have a width, right? So that area has to be 0, okay? So basically the probability of exactly one value or like 1 point on my x-axis is always going to be 0, okay? So if you're ever asked for an exact probability, 0, okay? Which means that basically if you're given a less than question in this class, it's the same thing as less than or equal to, because I'm just adding on one value and that value is 0, right? So less than, or equal to mean the same thing in this class, just for this section. And greater than or equal to, they also mean the same thing in this section, okay? So I wouldn't get confused between those two things, okay? Finally, the area under the entire curve is equal to 1, but we kind of already talked about that. Okay. All right, let's flip over to the next page and let's talk about how we can use these density curves to figure out certain probabilities, okay? All right, let's take a look at example number 1. Here we have a probability density curve. It represents the GPA of all these graduating seniors out of school. You can kind of tell that like a lot of people have like towards like the lower end of things, a couple people with like 3.5s and above, but we kind of have it all graphed here, okay? Let's say I wanted to find the proportion, which is the same as the area and the probability of seniors whose GPA is between 3.0 and 3.5. Well, if I wanted to find that, I guess I need to look at 3.0 and 3.5 on my x-axis, and I'm basically looking at the area between those two values. So taking a look at my graph, what is that area? There's an arrow pointing to it. 0.24, right? Because literally the question tells us what it is. So that wasn't too bad. I will say that in this class, well, the questions get a little bit more hard than while having an arrow pointing to it. Let's take a look at part B, okay? Part B is trying to find the area for a GPA of exactly 2.5. So this is an exact probability. I want to find the probability that it's equal to 2.5. What's the probability of this one? 0, right? Any exact probability in this section is going to be 0 because the area underneath one point is 0, right? So whenever you're asked for an exact probability, it's just 0. Okay. All right, let's do the last one. We want to find the probability that we have a GPA greater than 3.5, okay? Well, let's take a look at our graph. I know that 3.5 is up here, and greater than would be shading everything to the right of 3.5. Now, on this graph, there really is no arrow pointing to this probability. Any ideas on how I would get that area, Mike?
Just add them up and subtract from 1.
Perfect, right? I know that everything underneath the graph is equal to 1, right? So basically, if I take this area and subtract it from 1, I'll get the opposite, which is the other side, right? Okay, so let's go ahead and do that. Right. What I'm going to do is, first of all, I'm going to find the opposite event, right? So the opposite of greater than 3.5 is less than 3.5. Okay, and well, less than 3.5 is just adding together those two areas, 0.67 plus 0.24. Okay, and that gives me 0.91, I think. Okay, and then to find the opposite of less than, which is greater than, you're going to take that probability and subtract it from 1 to get 0.09. Okay, any questions on how I got A, B, or C? Okay. Example 2 is very similar. I basically have two normal distributions. I know the less than probabilities. I want to figure out like what the other probabilities are. I will say part B is kind of hard, but why don't you try A, B, and C, and then we'll come back. All right, I think we're on the right track here. Let me try to just go over these answers real quick, because this will become really important once we start adding Minitab to all of this. Okay, so basically what we have here is we have two normal distributions, but these two distributions only show us less than probabilities, not greater than probabilities, right? Now, one thing about this class is when we use Minitab for this class, Minitab is not very smart, okay? Minitab only can compute less than probabilities. So basically for any sort of situation in this class, we're going to be given information about less than probabilities, and I might ask you something about a greater than probability or a between probability or something weird, right? And because of that, I think we need some practice just dealing with it by itself. So I want to find the probability that Z is greater than 0.75. Well, 0.75 is on the left-hand side graph, so I guess we're focusing on that left graph, right? But the problem is the left graph gives us a less than probability. How do we get to the greater than probability? 1 minus, right? So I just need to take 1 and subtract off that left-hand side probability, 1 minus 7253. And did everyone get 0.2747? Sounds good. All right. So part A was pretty easy. Part B is a little bit harder because it's not like the other examples that I gave you, okay? Now, first of all, in part B, we have a less than sign and a less than or equal to sign. Does the less than versus less than or equal to really matter here? No, right? Less than or equal to, it doesn't really matter what is put there. All we really care is if it's less than or if it's less than or equal to. Okay. So let's just say I want to find this between probability, okay? I think it's easier if we kind of just graph these two numbers side by side, okay? So let me draw my normal distribution, okay? I'm going to put my 0.85 towards the right, okay? And I'm also going to plot the 0.75 towards the left, okay? I know it doesn't look very accurate here, but that's basically where I'm at, okay? Well, let me section off 0.85 and 0.75. That does not look very accurate, but that's okay. Okay. Now, my 0.85 probability, I can kind of highlight that, right? If I were to highlight less than 0.85, this is what my right graph is giving me. That what I have in orange is 0.9798. Okay. Let me plot the left-hand graph, but I'm just going to plot it on top of what I already have. Okay. So if I plot the left-hand graph, I'm basically shading everything to the left of 0.75. Okay. I think when they're on top of each other, it becomes really easy to tell how I should get the middle part, because basically, if I take what I had in orange and I take away the green part, now I'm left with what I'm interested in. Do we kind of see that? So does anyone can tell me in terms of like the numbers what I should do to get this probability?
You subtract 0.9798 minus 0.7253.
Perfect. You subtract the big probability minus the small probability to get that middle probability. So we should get 0.2545 as our answer for number one, or for number B. Okay. So basically, if you're ever given two less than probabilities, to get to the middle probability, you just subtract the two less than probabilities. Okay. Does that kind of make sense? Cool. We'll be doing that a lot in this class. Okay. Finally, if I want to find the probability that z is equal to just one number, what is always the answer? 0, right? 0 is always the answer for an equal to probability. Not because like it's not possible, but because the area underneath that 1 point is going to be 0 because it has no width, right? Okay. All right, let's flip over and just talk about the normal. Okay. So in this class, we are going to do a lot of different ways to find normal probabilities. And I think it's just good to kind of refresh ourselves on what the normal curve is and all the stuff that we know about it, okay? Now, right here, I have a picture of the normal curve. It looks like a bell, right? And it has some certain properties, okay? If I cut it right in the middle, I think we all know that the mean or mu is right in the center, right? And if I cut it in half, the left-hand side looks exactly like the right-hand side, right? Which is this property called symmetric, right? So we call the normal curve symmetric about the mean because, well, the left-hand side looks almost exactly like the right-hand side, okay? There are three important things that happen right in the middle. The mean happens in the middle. The median is actually in the middle because it's the middle, right? And the mode is actually in the middle because that's the peak of the graph. So the mean, the median, and the mode all happen straight in the middle of this graph, which is pretty useful when we take a look at some of its properties, okay? The last property is something I haven't talked about yet. If we take a look at the edges of the normal curve, okay? Now this graph, it gets really close to the x-axis, and in the graph, or in this picture, it actually does touch the x-axis, but that's not actually what happens in real life, okay? When we have the x-axis here, and we have a normal curve plotted, the normal curve doesn't actually touch the x-axis. It just gets really, really, really close to it, but never actually touches it, okay? So I know the picture looks deceiving, but this graph doesn't actually touch the x-axis at any point. Does anyone know what that's called? Starts with an A. Michael, you should know what it is. When something gets really close to something but doesn't touch it.
Approach.
Okay, it is approach, but there's Arna? It's an asymptote, right? You knew that. I knew you knew that, Michael. Okay, asymptote. And if we want to describe something that's or that has an asymptote, it's asymptotic. Okay. Expected better for my calc class, Michael. That's okay. I knew you knew it. Okay, so this is asymptotic to the x-axis, which means it gets really, really close to it, but it never actually touches it. Okay. Now, some other stuff that we learned about the normal distribution and just regular distributions in general, we can actually tell, like, if I'm given an x value, like x being like 2 or 7 or something like that, we can actually describe how far it is away from the mean based on how many standard deviations it is away from the mean. So let me just kind of write this out, okay? We can tell how high or low a score is based on how far it is above or below the mean, okay? And remember, the mean has the symbol mu, okay? And we can talk about how far it is above or below the mean based on the standard deviations, right? Standard deviations, okay, which uses that symbol sigma, okay? So we actually have a term for it, okay? Does anyone remember the term that talks about how far above or below we are the mean based on how many standard deviations it is. It rhymes with me door. Z-score. That did not rhyme. That was really bad. But the Z-score, right? The Z-score tells us how far we are above the mean, how far below the mean, and specifically it tells us how many standard deviations we are above or below the mean. Does anyone remember the Z-score formula? You have to know this for your test. I'll give you a hint. On the bottom, we have standard deviation. On the top, we have subtraction.
Minus the mean.
Minus the mean, good. And then what's the thing that we're subtracting? X, perfect. So it's X minus mean over standard deviation. That's how we go about finding the Z-score. Okay. So what else do we know about the normal distribution? The last thing we talked about the normal distribution was we have this thing called the empirical rule, or the 68, 95, 99.7 rule, which told us that if I was within one standard deviation of the mean, we had 68% of the data. We had two standard deviations of the mean, meant 95. And if we were within three standard deviations of the mean, that was almost all, or 99.7% of the data. Okay. Now this is useful and stuff. If we're constrained to 1, 2, and 3 standard deviations of the mean, but sometimes we're not interested in just like 1 standard deviation, 2 or 3 standard deviations, oh my God, away from the mean. Sometimes we want to know what the probability is between, I don't know, 0.5 standard deviations of the mean, or less than 0.8 standard deviations above the mean, or something like that, right? And to become more precise, we're going to have a way to find any probability with the normal distribution, not just being constrained to 1, 2, and 3 standard deviations away from the mean, okay? And before we talk about that, I do want to talk about Z-scores, okay? Now, sometimes in a question, we're not going to be given the actual situation. Like the question is not going to tell us what the mean is, and it's not going to tell us what the standard deviation is. In that case, we'll just use the Z-score, okay? And if we use the Z-score, we're going to use this thing called the standard normal distribution, okay? And what this is it's basically a normal distribution with a set mean and a set standard deviation where we can just figure out any probability without knowing what the mean or standard deviation is, okay? Now, the standard normal distribution has a mean of 0 and a standard deviation of 1. And what's really special about the standard normal distribution is that Z-scores follow it, okay? So whenever you're giving a Z-score problem, okay, you're going to use the standard normal distribution, and you're going to make sure that the mean is set to 0 and the standard deviation is set to 1, okay? Now, if this doesn't make sense right now, once we start doing problems, and we'll do a lot in this class, you'll see what I mean when I talk about this. But I honestly think the easiest way to go about this is just to show you some examples of what to do, and then we can talk about if we're confused later on. Okay, so how do we find these probabilities? There's actually a couple ways. Before we had technology in this class, we actually had a formula that you plug stuff into. It was very complicated. That kind of went away like 20 years ago. I think after the formula, we had these charts that you had to use to find normal probabilities. If you've ever taken a stats class before, you've probably used those charts before. And some teachers do teach the chart method. The reason why I use Minitab is because I'm literally required to teach you how to use Minitab for this. And instead of teach you like 2 different ways, I just think it's easier to show you the Minitab way, which is pretty much the same thing as using the chart. And just show you this way, because now you just have one way of doing it, so you're not confused as to which way to go about it, okay? So here's how we go about doing it. What we're gonna do is we're gonna click a bunch of stuff on Minitab. We're gonna type in some stuff for step 2 and 3. Step 4, we're just gonna make sure that it says normal, which it's kind of default to. Step 5 actually depends if we're given an X value or a Z-score. If we're given an X value, we're just going to type in the mean and standard deviation given to us in that question. If it's a Z-score, we're going to use the standard normal distribution. And I actually have a mistake up here. Does anyone see it? Oh, well, now you don't see it. Let's try that again. Oh, wrong one. What is it?
standard deviation should be 1.
Yeah, the standard deviation here should be 1, not 0. So make sure you type that in your notes. The standard normal distribution has a mean of 0 and a standard deviation of 1. So we're gonna make sure that happens. We're gonna click a bunch of stuff on Minitab and it's gonna spit out a probability, okay? The only bad thing about Minitab and the chart method, by the way, is that Minitab is really stupid, okay? Minitab does not know how to calculate any probability versus, like, when you're given a question, it can't just spit it out for you, okay? Minitab can only give you a less than probability, okay? So if your question is a less than question, then your answer is going to be your answer. If it's not a less than question, you're going to have to do a little bit more work, and we'll talk about what to do in that situation, okay? But before we talk about that, let's just go through example 2 and talk about what we would do for these questions. Okay, so what we're going to do is in example 2, or just think that all these questions are about the z-scores. Okay, whenever we're given like z in a question, we kind of just assume that we're dealing with a z-score, but it's good that the question told us. Okay, now part A, there actually is another typo on my little set of notes here. Okay, I wanted to find the proportion of z-scores that's less than 0.68, and then I wrote it again with 0.75. We're just going to adjust this question so that we're talking about the z-scores less than 0.75. Okay. I'm sorry I made 2 typos on the same page here, but we're interested in everything less than 0.75 here. Okay, well, whenever I do a z-score question, I like drawing a picture because if I see the picture, it just becomes really clear what probability I'm dealing with. Okay, since I'm dealing with a z-score, what's my mean? Michael, 0, yep. What's my standard deviation? 1, perfect, right? Whenever you deal with a z-score, we use the standard normal distribution, which tells us the mean is 0 and the standard deviation is 1. So on my graph, I can literally plot 0 right in the center, and I know that each standard deviation is 1 away. Okay, now is 0.75 as a z-score, is that above the mean or is that below the mean? Did I hear above? I couldn't hear what. Above, right? If it's positive, it's above the mean. If it's negative, it's below the mean. So I would say that 0.75 is kind of like close to 0, but just kind of a little bit closer, okay? So I'm gonna plot 0.75. I'm gonna kind of mark it where it is on my graph. And if I'm interested in the z-scores less than 0.75, should I shade in the area to the left or to the right? So is less than to the left or to the right?
Left.
To the left, right? So let's just shade in everything to the left of 0.75. This is what I'm interested in, finding the proportion, probability, area, whatever you want to call it. Okay. Now here's where the big thing comes along. We're going to use Minitab to find this probability, which means we need to follow all the steps in that yellow box. Okay, so let me show you what to do here. All right, so we are going to go to Minitab. Okay, on Minitab, I'm just gonna, if I can get rid of these, you don't see, oh my gosh, my session has expired. Oh, I hate it when this happens. Okay, we're gonna try it again. You know, I thought I was all prepared doing this before, but gosh, okay. Yeah, it didn't help. All right. So we're gonna follow the instructions. The instructions tell me to first click on calc, then click on probability distributions, okay? And we have 3 options here. With the binomial distribution, we actually click the probability density function on the bottom. We're not going to click that anymore. We're going to click on cumulative density function or cumulative distribution function. And that's because we're dealing with a, a continuous variable instead of a discrete one. So we're going to click on that. Okay. The form of input, we're just going to leave as a single value because we're just going to type in a number we're interested to find. What do you think is going to go in for the value? 0.75, right? Because that's what we're interested in finding the probability of. The distribution, there's actually tons of distributions that we can use. It's kind of just default set to normal. So we're just going to keep it as normal. Do my mean and standard deviation look good? Yeah, right. Since we're dealing with a z-score, the mean is 0, the standard deviation is 1. Output, we're just going to kind of leave the same, and we're just going to click OK. And whoop, here we go. We get our z-score on the left, which it says x, but it just means the z-score. And then on the right, we have the probability of less than that z-score. So 0.7733. Okay. Any questions on how I got this value on Minitab? All right. Pretty easy. Let me kind of flip myself back to my screen here. This is like the most annoying thing about using my iPad is going back and forth. But it's all good. Okay. So on my set of notes here, I just kind of wrote what Minitab spit out at me. Now, Minitab can only do left side probabilities, right? So is this answer my answer? Or do I have to do anything to it? Well, Minitab only does less than probabilities. Is this a less than probability?
Yes.
Yes, right? The question is asking us less than. So since we have a less than question, this is literally my answer. So my answer is the 0.773373. Okay. If this question was a different question that asked me like a probability of in between numbers or greater than or something like that, then my answer would be a little bit different. But since less than is what Minitab excels at, this is my answer for part A. All right, let's flip over to part B. Okay. Now, part B is very similar to part A, right? Except this time, instead of asking less than 0.75, I'm asked to find less than or equal to 0.75. What do you think I should do for this question? Do you think?
The exact same thing.
It's the exact same thing, right? For this question, it doesn't matter if I have a less than or equal to question, right? So literally my answer is going to be the 0.773, 373. It literally stays the same. We don't care if it's less than or equal to. It all just means the same thing in the section. Okay. Part C asks for the probability that z is equal to 0.75. What is always the answer for these equal questions?
0.
0, right? So that one's pretty easy as well. All right. Let's do part D. This one's asking me to find the probability that z is less than negative 1.38. Let's just plot this on my graph here. Since I have a z-score, I know that my mean is still 0, and I know that my standard deviation is still 1, right? On my graph, if I want to plot negative 1.38, it has to be below 0 because it's a negative score, right? And if it's less than, should I shade to the left or to the right? The left, right? Because less than is to the left. Okay. Now, I know the answer is like right there, but I do want you to just try clicking this on Minitab, just so you're familiar with what to click on. I just want to make sure we can all get to it in class. Okay, are we all getting it? Is anyone having trouble? Looks like we're good. Okay, that makes me feel good. All right. All right, so we all got the 0.08 thing as a output, right? Good. Is 0.08 our final answer? Do we have to do anything to it? So Minitab only can do less than probabilities. Is this a less than probability? Yes, right? So we don't have to do anything to this. This is literally my answer. Okay, so my answer is 0.0838. Okay. All right, let's go to part E. Now this question is going to be a little bit different, right? This time I want to find the probability of between negative 1.38 and positive 0.68, okay? Now here's where it gets a little bit more complicated because now we have to figure out, okay, like are we, where we're not just doing a less than probability, right? Before I go about doing this, let's just try to draw what we're doing here. Since this is a z-score, my mean is still 0, right? And negative 1.38 is probably around here. So I'll draw that line up. 0.68 is kind of closer to 0, so I'll draw it here and draw my line here, okay? And if I want to find the probability of between these two values, I'm just shading in everything in between. Okay, so this is the area that I'm trying to figure out. This is very similar to that one example we did with the probability distributions. But let's just go ahead. Okay, now when we have between probabilities, here's what we're going to do. Okay, so let me write it out. Between questions. Okay, the first thing you're gonna do is you're just gonna type in both of them into Minitab. So you're gonna go in Minitab, okay? You're going to find the probability of negative 1.38, okay? And then you're gonna go in a separate Minitab thing, and then you're gonna find the probability of 0.68. Okay, so you're not going to do them together. You're going to use two separate Minitab commands. You're going to do negative 1.38, and you're going to get this guy here on the left. Okay, you're going to do 0.68, and you're going to get this guy on the right. Okay, does anyone want to see me do this, or do you feel good? You want to see me do it? Oh, are you good? Okay. So let's just say I did Minitab twice. I got negative 1.38. I got 0.68. Okay. Let me explain what these two mean. Okay. Remember, Minitab can only do less than probabilities. So this probability right here is telling us the probability that we are less than negative 1.38, right? So this is a less than probability here. This one right here is a less than probability of less than 0.68. Okay. So this is this probability. Does anyone remember what to do when we have two left side probabilities and we want to find a between? Yeah.
Subtract the bigger minus the small.
Yep, that's literally all you have to do, right? So all you have to do after you do Minitab is you subtract, okay, big probability minus the small probability. Okay, and that's all you have to do, okay? So your final answer for this question, final answer, is to take the 0.751748, the 0.08379333. You're going to subtract them together to get 0.6679, and that would be your final answer. Okay. So let's just kind of recap this. To find a less than probability, you type stuff into Minitab, and what you get is your answer. If you want to do a between probability, you take the big probability and subtract off the small probability. Okay. Let's talk about what happens when we have a greater than probability. Yeah.
So I have a question about that answer because it's 0.66795. Wouldn't you then round up to 667?
Oh yeah. So it should be 0.66780. Thank you. I did this in my office when I was like tired. So I actually did this in my office like 2 years ago. So no one really caught that yet. All right. All right. Any other questions? All right. Let's talk about what we do with a greater than probability. In part F, I want to find the probability that Z is greater than or equal to 0.35. If I want to draw this on my graph, since I have a Z-score, I know that my mean is 0, right? I know my standard deviation is 1, and I know that 0.35 is greater than 0, so my 0.35 is going to kind of go to the right. Let me mark off what I'm talking about here. Now, for a greater than probability, should I shade to the right or to the left? The right, perfect. So this is what I'm looking at here, okay? So what you're going to do for greater than probabilities, you're just going to do the same thing that you did before, okay? Let me kind of just show you just because I'm not, I'm kind of paranoid like that, okay? You're going to click on calc. You're going to click on probability distributions. You're still going to click on cumulative. And you basically do the same thing as we did before, but just type in what we're interested in. So 0.35. So everything you do on Minitab is the same thing that you do for the other questions. We kind of just interpret it differently at the end. So we're going to click OK, and we get the 0.636831. Okay, so everything here just stays the same, even though it's a greater than question. Everything you type on Minitab is all the same. Okay, let's just figure out what we do with our answer. Okay, so this is what Minitab pops out. Okay, the problem with this question is the thing that Minitab pops out is the less than probability. This isn't a greater than probability. So what should I do with this 0.636? Subtract it from 1, right? So if you have a greater than probability, okay, question, you're going to go into Minitab. So you're going to do Minitab. And then you're going to subtract it from 1. Okay, so your final answer here is going to be 1 minus 0.636831. And let's see if I did this one right. I got 0.3632, I think. All right. Any questions on how I got part F? Okay, cool. So basically what we learned is if we have a z-score, the mean is 0, the standard deviation is 1, right? If we have a less than probability, it's just the answer. If we're doing a between probability, you subtract the two together. And if it's a greater than probability, then you subtract it from 1. Okay. Any questions on these guys? Sounds good. Okay, there's one last thing I want to talk about before I end class, and it's the test. Okay. I'm just going to go to the test study guide real quick on my classes. On the study guide, I do have some practice questions. And if you go all the way to the bottom, you'll see that the last 2 questions have to do with the normal distribution. Since we went over something exactly like number 14, like today, I think I'm gonna do something like number 14 on the test, but we haven't gone over number 15 yet. So when you're studying for the study guide or for the test, kind of ignore number 15. Definitely know how to do 14, but don't look at 15.